So much drama in the LBC. It's kind of hard being Snoop D-O double G, but I somehow, some way keep coming up with funky ass shit like every single day.
Hello and welcome to the practice problems video for the section on linear functions. Okay, here's problem number 1. It says a town's population has been growing linearly. Okay, so it involves some kind of linear function. In 2003, the population was 45,000, and the population has been growing by 1,700 people each year. Write an equation P of t for the population t years after 2003. Okay, so we know, because it says it's a linear growth here of our population, we know that it has to have the form of y equals mx plus b. Okay, where m is our slope and b is our y-intercept. And in this case, they want us to use the notation p of t for our function. Okay, so we'll have p of t is equal to sum m times t plus b. Okay, not a big deal. We just switch the names of the variables and everything. Okay, so the thing is we need to find b and we need to find m, and then we'll have the equation for our population. Okay, so b, what is b? That means when t equals to 0, then what is the value of our function? Then p of 0 is equal to what? Okay, so what is t? That's what we have to look at. What does it mean for t to be equal to 0? So if we look at the very end of our question here, it says for the population t years after 2003. So that means, let's say, t equaling 1 means that it's 1 year after 2003, so that corresponds to the year 2004. So if we go back, t equals 0 means that we're talking about the year 2003, right? Because that means 0 years after 2003, so that means we're still in that year, okay? So p of 0 would be given by what is the population in the year 2003. And lucky thing, the problem provides that for us. It says in 2003 the population was this guy right here. So p of 0 is equal to 45,000. Thus, we found our y-intercept, or our b, okay? So b is equal to 45,000, and we have one part down. Now our job is to find, okay, so now what's the slope? What's our m? Okay, so let's read the problem again. So in 2003, the population was this amount, and the population has been growing. So this denotes some kind of change in our function, right? Change in our function, and the rate is by 1,700 people each year. Okay, so m is going to be equal to 1,700 people each year. So that just gives us a slope of 1,700, right? So to put it all together, we would basically just get p, capital P of t, is equal to 1,700 and times t plus 45,000. Okay, and this represents the population t years after 2003, because let's just break it down one more time just to review. So what we have is that when you plug in t equals 0, we can just check. So t equaling 0 would be 1,700 times 0. So we haven't added any of the slope. That hasn't contributed at all. And we're at 45,000, which is good we because that's what they told us in the beginning. And then any time after that, so when t equals 1 or anything like that, then we have that we keep adding 1,700 to our population each year as each year passes. Okay, so this is it. This is our answer for the linear function, which kind of represents the population of this town. Alright, here's number 2. We're going to determine if each function is increasing or decreasing. So firstly, let's review. So m being less than 0 means our function is decreasing, and if m is greater than 0, that means our function is increasing. Okay, so let's look at these two functions. It's kind of like a two-part question here. So f of x is equal to 4x plus 3. We see that the coefficient of x, which is our m, right, that's our slope, m is equal to 4. M equals to positive 4, which is greater than 0. So we have an increasing function. So f is increasing. Alrighty, and then if we look at this one, we have, well, the coefficient, or what comes right in front of x, is a negative number. So that means our slope for this one is equal to negative 2, which means it's less than 0. So this one here is decreasing. Okay, pretty quick question there.
With my mind on my money and my money on my mind.